This is part 4 of chapter 1. We're looking at example 22. We want to divide 1 2/5 by 7/9. The rule for division is keep it, change it, flip it. You keep your first one, you change it to multiplication, and then you flip your second one. And then you have a multiplication problem, and we know how to work those. But really what we want to do first is when you have a mixed number, it's really hard to multiply, divide, or add or subtract when it's in this form. I strongly suggest that you multiply and change this into an improper fraction. So we do that by around the world. What we're going to do is 5 times 2. Remember, a dot can sometimes be multiplication, and that's the one I tend to use. But I'm going to multiply here and then add here. 5 times 1 is 5. 5 plus 2 is 7. So 7 over 5. 7/5 divided by 7/9. Okay, so now we have it in improper fraction form. Now let's do this. You keep your first one, change it to multiplication, and flip your second one. Okay, now this is our multiplication problem. We can multiply straight across the top, straight across the bottom, and then reduce our answer. There seems to be a helicopter going overhead. I apologize for that. Okay, but we can also reduce on the diagonals. I have a 7 here, a 7 here. So if I divide both by 7, that gives me a 1 there and a 1 there. And now if you multiply straight across, you get 9/5. Okay, if they're looking for an answer as an improper fraction, this is what you would give them. If they ask it for a mixed number, we've talked about how to switch it from mixed to improper. We have not talked about improper to mixed. Treat this like a division problem that it is. And I'm going to show you in basically elementary school division form. 5 divided into 9. 5 goes into 9 one time. 1 times 5 is 5. You subtract, and you get a 4, and this was your remainder. When you first learned division, that's how you talked about it. To write your answer as a mixed number, this is the whole part, so it's 1, and your fraction is 4/5. It's always your remainder over what you were dividing by. So this is 1 4/5. That would be the answer they're looking for. Okay. Give the answer to the following problem in simplified fractional form. 1 over 300 times 60 times 1 over 0.4. Okay. So what I'm going to do first is I'm going to rewrite this as 60 over 1. Okay, now I see that I have a diagonal that I can reduce on. I don't like having a decimal in here, so even though I could probably reduce the decimal or change this into something else, you have a calculator. I don't see the use in doing that. What do I have here? 60 and 300. Well, I can tell quickly that they're both divisible by 10 because they both end in a 10. And if I divide by that by 10, that's a 6 and that's a 30, correct? All right, so now I have a 6 here and a 30 here, and that reduces further. If I divide this by 6, I get a 1. Divide 30 by 6, and I get a 5. So if I divided this by 60, I would have gotten a 1. Divide 300 by 60, I would have gotten a 5. I did it in 2 steps instead of 1. Now let's multiply straight across. I have 1 times 1 times 1, which is 1, over 5 times 1 times 0.4. So this is 5 times 0.4. If you have parentheses that are simplified on the inside, but they're side by side without anything between them, that's a multiplication. I could have written 5.0.4, although that can be a little bit confusing because of a decimal and a dot. I could have done 5 times 0.4. The reason I tend to not use this is because I teach algebra, and an x in algebra, we never use an x for multiplication anymore. But that's what this means, and then you can use your calculator and multiply 5 times 0.4 to get 2. So this answer is 1/2. Okay. 24. Give the answer to the following problem in simplified fractional form. Well, this is 0.35. We can think of that as over 1, correct? This is a decimal. That's not. Let's just multiply straight across, and I get 0.35 over 60. Okay. I can try using a calculator. 0.35 divided by 60, but I'm going to get a big ugly decimal, which does not help me here. Okay, so what I want to do right now is I need to get to a fraction that I can reduce. But right now I have a decimal here and it's causing me some problems. So what I want to do is I want to get rid of this decimal. I have 2 decimal places here. So I need to move this decimal place 2 over in order to make my decimal go away. I need to move it 2 places, so I'm going to multiply this by a 100 because the number of zeros is how many decimal places this thing moves. But if I multiply the top of a fraction by something, I also have to multiply the bottom of a fraction by something. 0.35 times 100 is 35 over 60 times 100 gives me 35 over 6,000. Okay, now that ends in a 5, that ends in a 0, so I know I can at least divide both sides by a 5, both of these by a 5, not both sides, divide by 5. 35 divided by 5 is 7. 6,000 divided by 5 is 1,200. 7 is a prime number, meaning the only numbers that divide evenly into 7 are 1 and 7. So unless this is divisible by 7, this is in lowest terms. So I try it on my calculator if I don't know. 1,200 divided by 7, I get a decimal, which means this does not divide evenly. So 7 over 1,200 is the answer they're looking for. Okay, 25. This is similar. This is 0.88 over 1 times 1 over 2.2. So what I'm going to do is you multiply straight across over 2.2 because I'm multiplying each of these by a 1. Now, I can do what I did up here and get rid of the decimals and then reduce it. But I always go to my calculator first because sometimes you get something very nice and you don't have to go through all of that. It doesn't take that much extra time, and it's really useful. Okay, so I did this division and I got 0.4. I'm going to kind of come over here, 0.4. I'm wanting my answer in fractional form. Okay, so what I could do is I did my calculator, it gave me this as a decimal. Well, this is 4. Remember that the first decimal place is tenths, so this is 4/10. And then if I divide each of these by a 2, I get 2/5. So 2/5 is my answer. That's one way of getting it done. Okay. If you didn't see this, or you tried it on your calculator and you just got an ugly decimal, and by the way, why is this decimal okay and the one we got up here was not? Because this one ended. That's the big thing, because this one ended. This one, when I did the division, it would never, ever, ever end. Okay? Let's look at this, though. Let's say I want to do this by getting rid of my decimals. Okay, this has 1 decimal place. This one has 2. So this one is the one I need more work on, so this is the one I'm going to focus on. I need to get rid of 2 decimal places, so I'm going to multiply this by 100. Now to get rid of this decimal place, I only needed to multiply by 10. But whatever I do on the top, I have to do on the bottom as well. So multiply that by 100 as well. This gives me 88 over 220. Okay, so I'm not quite sure the largest number that divides evenly into these, but I know what 2 does because they're both even numbers. So let's try that. Let's get our numbers smaller. If I divide each of these by a 2, that gives me 44 over 110. Those are both even, so I could divide by 2 again, which will give me 22 over 55. Now, repeated digits, these are divisible by 11, which gives me 2/5, which is what I had right here. Okay, example 26. I have 1/25 times 500 divided by 1/4. This is what we call a complex fraction. It is a fraction that contains fractions. Okay, so what this means is, this is my main fraction bar. We said that our main fraction bar is a grouping symbol, meaning you need to calculate the top and you need to calculate the bottom and then deal with that fraction at the very end. So at the top, let's figure this out. I'm going to say, come over here to scratch paper. And I want to figure out 1/25 times 500. Let's do this over 1. Okay. Now 500 is divisible by 25 to get 20. So if I reduce here, divide that by 25 and get a 1, divide this by 25 and I get a 20. So this is 20 over 1, which is just 20. You can lose a 1 that's in the denominator. We cannot lose a 1 that's in the numerator. So this top part, this is 20 over 1/4. The biggest tip I can give you when you're dealing with complex fractions is to make sure that your main fraction bar is significantly larger than the other. Otherwise, it can get very confusing. Okay, so how do I deal with this? Remember that a fraction bar is a division. Fractions are divisions. So this is exactly the same thing as 20 divided by 1/4. The top of our main fraction bar over the bottom, even though that's a fraction. Okay? Remember, when you're dividing by a fraction, you keep it, change it, flip it. So this is the same as 20, keep the first one, times the reciprocal of 1/4, or 1/4 flipped, is simply 4. So I end up with 20 times 4, which is 80.